Okay, the first half of this solution stoichiometry I'm going to dedicate to actually making a solution and showing you how to use the concept of solution. And then we're going to do some stoichiometry with it. So, a couple things you should remember. A solute versus a solvent versus a solution. Together, a solution is a homogeneous mixture. And that is usually like something like an NaCl solution, and typically when we talk about an NaCl solution, we're talking about solute, which is the NaCl. It's what is dissolved, and usually lower quantity, and in this case it would be the sodium chloride. And then the solvent, in this case, most of what you'll ever see in general chemistry and biochemistry, the solvent is water, but what is dissolving, the solute, which is really cyclical, but in this case, in terms of logic, but the solvent is the thing. There's usually less of this and more of this. If you had a really concentrated solution, I guess you could make an argument that those would flip-flop, but for the most part, your solvent is the thing that you have more of. So the term that we use when we want to know how much stuff is actually dissolved, like how much sodium chloride solution, or you've made juice before where you dilute it and you know that the more water you add, the more it becomes like water. So we have a term of what's called a concentration term in chemistry. We use the concept of, it's an R, molarity. And molarity, we use a big M, but it is moles of solute, so in this case NaCl, over liters of solution, so of the whole solution. And why this is really valuable is if we take molarity, and sometimes people use a little m, I usually use just mol or mole, and you multiply it by volume, you get the moles of solute. And this is really valuable. And I'll always give you that equation, or you could look it up. Molarity of a solution times the volume is moles. And remember, this is moles per liter, and this is liters. Those liters cancel, and you end up getting moles. Okay, so I'm going to talk to you, and I want you to know two different ways of calculating a solution concentration, or making a solution, because this is what chemists live and die by, is if they know how much is in the solution and they know how much they delivered, they know how many moles they've delivered. So let's try this. So I'm going to talk about making a solution two different ways, creating a solution. And not just a solution like you could throw salt in water and you've made a solution, but creating a solution of known concentration. So you need to know two things when you're doing this. You have to know how much solution you want to make, right? So 10 milliliters, 100 milliliters, a liter, 2 liters, 10 liters, and the concentration. So how much stuff you want actually dissolved. So those are the two things that we need to know. So I'm going to first start with making a solution from a solid solute. And obviously it would have to be able to be dissolved in order to do this. So let's say I wanted to make 500 milliliters of a 1.50 molar NaCl solution. So you'll see that what we have to first figure out, if we know the volume and we know the concentration, we can solve this problem. So we want to figure out how much we actually have to make. So I want you to be able to do the calculation, and then I want you to explain to me the physical component of this. And if you do this in lab, this is the process you'd make. So first, figuring out the number of stuff you need, how much sodium chloride. If you just have a container, you have to use this concept of molarity times volume equals moles of NaCl that you need. Now, remember, this is moles per liter, and this is in milliliters, so this has to be converted. So I always think the best thing to do is, if I'm going to multiply molarity by something, this can actually be moles per liter, or it can be written as moles per 1,000 milliliters. And that's typically how I do the conversion instead of going and converting this to 0.5. So I would say 1.50 moles of NaCl over 1,000 milliliters, that's the same as over 1 liter, times 500 milliliters. So if I do this math out, the milliliters cancel, and it tells me that I need 0.750 moles of NaCl. Now, you can't weigh out 0.75 moles on a balance. You have to convert that to grams, and so I'm going to do that on the next page. And I'll say I have this 0.750 moles of NaCl, and the molar mass is 58.45 grams. Remember, off the periodic table, for every 1 mole. So the moles cancel, and I get 43.8 grams of NaCl. Now, so I'd have to do, that's great. Now I have to know how, how am I going to make this solution? So the way I'd make this solution is I have to use what's called a volumetric flask. And that volumetric flask, it looks like this, and it's got kind of a round bottom, and then it goes up. And this is basically, has 500 milliliters on it. And then there's a line that's scribed on it, like right here. And you always need to fill up to, with the bottom of the meniscus at this line, and then this would be 500 mils of solution. So you don't add 500 milliliters. So you don't put in this 43.8 grams and then add 500 milliliters, because this actually takes up space. This occupies space a little bit, and it would cause the volume to go up. So what you do is, the first thing is you fill the volumetric flask, and I want you to know that specific piece of glassware halfway with water. And then what you do is you add your solute, okay, and dissolve it. So you kind of slosh it around, mix it up, and then you add water to the line, and then you mix well again. Some people say you invert it 20 times or whatever. It doesn't matter. It just needs to be mixed well. So you can't see any of those squiggly lines that are in there. But that's how you'd make the solution. So you need 43 grams, 43.8 grams. You'd weigh out on a balance, and then you dissolve it. Okay? Now, there is one other way. Maybe I'll give you a quick example here so you can practice it. So if I asked you a question, explain how to make 250 milliliters of 0.150 molar calcium nitrate. And I'll put from solid calcium nitrate. All right? So I'm going to pause. You can pause the video and tell me how you do that. Okay, so you know that you have to take molarity times volume to figure out how many moles of solute that you need. So I would put this, because the volume is given in milliliters, I would put this 0.150 moles of calcium nitrate in 1,000 milliliters. That's what it means to have a molarity, times 250 milliliters. Milliliters cancel, and you get 0.0375 moles of calcium nitrate. Now, you can't do this by calculating moles of you can't measure out moles, so you have to convert this to grams. So you have to take your 0.0375 moles of calcium nitrate. Just have to get proficient at these calculations. 1 calcium, 2 nitrates, and 6 oxygens gives you 164.10 grams for every 1 mole. You can use the periodic table. That's the molar mass. Right? When you calculate that out, you get 6.15 grams of calcium nitrate. Now, in order to do this problem, I would ask you, this is the math. This is most of the points for problems like this. But then you have to follow the instructions that I gave you last time and explain that you fill the flask halfway with water. You'd use a 250 milliliter volumetric flask. This is a 500 milliliter. You'd add the solute and you'd dissolve it, and then you'd add up to the line. So I'd want you also to describe how to make it. And you'd use a 250 milliliter volumetric flask in this case. All right? So that is one way of figuring out or making a solution if you have a solid. But a lot of times you'll have a solution that is already made, and what you have to do is dilute it. So the second way is making a solution from dilution. And you might have heard that term before. The solution to pollution is dilution. And dilution really just means you add more water in this case, but any type of solvent will dilute a solution. So conceptually, think about what you're doing when you dilute something. You're not changing the amount of stuff. Like if you have a beaker full of a container, if you have a beaker or a container full of, let's say this was 50 milliliters of water or whatever, and you had 2 things in here. If you poured it into a bigger beaker, like a 500 milliliter beaker, and you added water and you just dumped this in here, you would still have those 2 items, no more. It's just there'd be a higher volume. This is an example of dilution. And so I always think the best conceptual idea is that your moles of solute before the dilution are equal to the moles of solute after the dilution. So nothing has changed, it's just you have a lower concentration. So if you were to take a glass of orange juice and add water to it, you still have the same amount of sugar in both the pre-diluted and post-diluted. So hopefully that makes sense. And so what we do is we use this equation where we say the molarity of this solution times its volume, because remember that equals moles, is the molarity of this solution times this volume. And sometimes we put C for concentrated and D for diluted. So this is concentrated and this is diluted. Or even more generically, people sometimes put M1V1 equals M2V2. And this is what I typically use and most people do. So just remember that your moles before equal your moles after. Okay? So to solve a problem, all we have to do is it's an algebra problem. So I have to give you, if we're going to do an M1V1 equals M2V2, the only way to solve this with 4 variables is to be given 3. You have to have 3 of these to solve. So if I asked you how many milliliters of 12 molar HCl, so concentrated, are needed to make 250 milliliters of 2.50 molar HCl. So we know that this is a higher concentration. It's a molarity, so it's an M concentrated or M1. This is a volume and this is a molarity, and they're connected to one another, so they're V2 and M2. So this is a concentration, I know, because of its unit, a molarity, and this is a volume. So I just have to plug them into this equation up here to solve this. So I say 12.0 molar times V1, I don't know what that is, equals 2.50 molar times 250 milliliters. Now, if you say, you told me molarity times volume has to be in liters, when this has to be in liters, it does if you're multiplying them to get moles, but here we're doing a proportion. So if I put milliliters here, I'm going to get milliliters here. But if you want to convert it to liters, you can, but it won't matter. So I divide both sides by 12.0 molar, and this one will cancel out, and then I'm basically taking 2.5 times 250 divided by 12 in my calculator, and I get 52.1 milliliters. Now, that's the volume, so you'd have to follow the same instructions. So you would take a volumetric flask. In this case, you would use a 250 milliliter volumetric flask, and you'd fill the volumetric flask halfway with water. You'd add 52.1 milliliters of 12 molar HCl. And mix. You'd add water to the line, and then you would mix well. All right? Now, one of the things you should always know when you're making solutions is that when you're doing this, you need to make sure that you add things to water. Concentrated acid should never be, water should never be added to it. You add things to it. So if they have that phrase, if you do what you oughta, you add acid to water. And so adding things to water is better and safer than doing the opposite. And it's because of heat can build up, and it can cause kind of a pressure kind of eruption. So anyways, I'm going to give you a problem just like I did with the other one. So I want you to try one. So if I asked you the problem, describe how you would make 100 milliliters of 1.25 molar NaOH from 5 molar NaOH. I'm going to pause the video and give you a chance to try this. Okay, so M1V1 equals M2V2. I know it's a dilution because I'm given 2 molarities. So I know that I ultimately want 1.25 molar times 100 milliliters, and I'm given 5.00 molar, and I don't know volume that initially I want. So divide both sides by 5 molar, cancels on this side. So I take 1.25 times 100 divided by 5, and you get V1 equals 25 milliliters. And I said describe how you would make that. So you would obviously need a 100 milliliter volumetric flask, and you would follow your rules. Okay, you'd fill this halfway with water. You would add your 25 milliliters. You'd mix it, and you'd make sure you add up to the line with water. Okay, so those are the two ways that you make solutions. In the next video, what I'm going to do is show you how we use these to do stoichiometry.